Database, database, database. There are so many different meanings to this word, and every person can understand it differently. So 50 years ago, when computers were not as omnipresent, database was like a set of maybe documents about patient, database of a hospital. It was like medical files of patients or the accounts that have been paid by patients. It was a database of accounts. Nowadays, people who are not in IT or software development, they can hear the word database, in news. They can hear that, for example, certain database of users with their personal details have been exposed to bad actors and the data has been leaked. Or when you call to your hospital to schedule an appointment, you may say that, oh, okay, I can't find you in our database. What was your date of birth again? And that's how they hear a database. But usually people understand database as basically the collection of data, database. In this specific video, we will be looking at database from IT and software development POV, and why databases are really more common than we think about them. Why do we interact with databases of web servers on a daily basis? So we will look at architecture of a basic architecture of traffic flow of a web application, which does include a database, and how databases have been transformed from tables on pieces of paper, from, let's say, maybe patient booklets or different types of databases that governments would have. For example, Roman Empire did a count of population in order to understand the number of people they have, their maybe gender, their age, and this was probably kept in their database. So our number of people is this, a certain amount of are women and certain amount of them are men, etc., etc. So how databases transformed and how they look at the moment in 21st century. So let's start. So we need databases for a structured collection of data. The data that we need to be collected in one place, right? If we wouldn't need the data to be collected in one place, for example, my classes that I will be studying at university, nap schedules that I had in my childhood, right? Nap schedule when I was a toddler. How is these two pieces of information are related? There is no relation between them. That's why we wouldn't add them to a single database. So database is a collection overall, is a collection of information that matters to the collector and that is somehow related to the collector, right? So this is a collection of specific information, the information that we are collecting. And there are two types of databases, depending on how they are presented and how they are treating the data. This is a relational database, and there is a non-relational database. You might have guessed, okay, relational database, there is some relation. And obviously your guess was correct. In relational database, we have a certain value, certain column. Well, to start with, relational database is always in tabular form. Tabular, right? We have a certain column, certain value that unites different tables. And it's usually very self-explanatory. It can be an ID, user ID, patient ID. I don't know, if it's a hardware, then their MAC address, their ID, right? We have certain identifiable information by which we connect the data collected, right? So for example, we have a certain class at the university and the students have their IDs. IDs are presented in numerical format. I'm talking about my specific example, okay? There can be student IDs that are not in numerical format. So my student ID at my bachelor was numerical. And then in one of my masters, it was a mix of numbers and letters. So treat it as my specific example, okay? So we have an ID, which is integers, like collection of integers. Then we have their class, which can be characters. And we have year of graduation, which is integers. And we have their hobbies, which is characters, set of letters. So we have certain information about the students that is not limited to this table, but we know the ID of each student. So by their IDs, we can put together different tables. So first of all, by their IDs, we can generate a table with their ID and name. So for example, 111 Anne Smith. Okay. 113 John Doe. By their IDs, we can get a list of their GPAs. Again, there will be an ID and there will be a list of their GPS. By their IDs, we can see a full table where we have full information about them. Because you might ask, okay, but what if I want to see full table? Why do I need like to have smaller, simple tables? Well, you can. You can have a bigger table where you have their ID, okay, their hobby, their name, and etc. etc. Table of full data. And at the same time, you might have smaller tables. But again, all of these tables related because they have a common denominator. They have an ID of the students. And this is important because imagine you want a report. You might need to use them for different applications. For example, the data is being collected. Users are entering their details. It can be this university students. University students enter their details and we use the data in the database for different applications. For example, finance department may use their student IDs and outstanding charges information. And they're like, okay, these users with this ID have these outstanding charges. And we can add another column, name. Okay, this user's name is Anne Smith. Anne Smith has certain outstanding charges. Let's follow up with her. And another department, library department, can have a totally separate query in order to access certain data. When we go to queries, there we come to SQL, simple query language. SQL is usually a source of fear for many people. Like, SQL, oh my god, I don't know what SQL is, SQL. But in reality, SQL is not as difficult when you understand its role in how we query the data in database. Because a bank can have millions of accounts. And you can't obviously comb through these accounts to look for the account information that you need, right? There where SQL comes into play. Basically, SQL helps us to query the database. It helps us to come, knock on the door and ask, can you please, from users between the age of 16 and 21, show me users who have outstanding charges. You can have all of these conditions using an SQL. If you Google SQL sample lines, you will see the programming language, the language in which it's written. As Python, as C++ has its own, they have its own syntax, just as SQL has its own syntax too. And it's very self-explanatory. It's very easy to understand. For example, when we say from, it always needs to be capitalized, from certain database, find me something. And that's how we query database. And we don't usually have to do it ourselves. We can create applications that query database on our behalf and show us the ready report. So for example, I'm a person who have no clue whatsoever in SQL language. I don't know how to query it. But at my work, I have an application. I can go to outstanding charges tab of finance application, and there I will have a list of people who have outstanding charges. But what did happen on the background? That finance application queried database that we had, and it pulled all the information about outstanding charges with the user IDs for each user. And now we have them, but I don't know SQL. It all happened in the background, right? That's why we need SQL. Sorry, I call it SQL, but many people also call it SQL. Well, whenever you hear RDS, Relational Database, whenever you hear SQL, whenever you hear MySQL, Oracle, PostgreSQL, it means that they are all referring to relational databases, all of them. And it's important to understand for your certifications because they sometimes say, oh, he needs an SQL database. This usually means that they need a relational database, and that will help you to filter through potential answers. If many people to whom I've spoken to understand relational databases, when it comes to non-relational databases, they're like, okay, what do you know about them? I know that they're non-relational, then maybe there is no relation between user ID and the name. Is that correct? And the answer is yes or no, but we have a deeper meaning to a non-relational database. It's not only when we don't have an ID address, that ID that unites all of these rows, unites all of these observations or rows, however you call them. Non-relational database, it means that the data shouldn't necessarily can be kept in a tabular format. It's non-tabular. So you make a call on how to keep your data. You can keep the data in the form of documents, right? MongoDB is a very popular type of document-based non-relational database. You can keep your data in a key-value pair, right? Redis is very popular key-value pair database. Key-value meaning, for example, what can we say? Okay, so we can say fruit, apple, vegetable, carrot. We can again have fruit, melon, right? So we have a keys, fruits, and we have value for these keys, which is followed by the key, right? Key value. But the most basic representation of non-relational database is JSON file format. This is one of the just file formats, just as we have Word document, we have an Excel document, XLS, we have Word docs, docx, and etc. We have PPT, PDF. JSON is a file format. In JSON, many things depend on indentation. On indentation of brackets especially. That's how it lets you understand when we finish with one enter, with one observation and go on to another. When I say observation, it just means that with one record and go on to another. So an example JSON file, we have rectangular brackets open, then another type of brackets, and I have ID in quotation marks 1, name John, bracket opened, bracket closed. Again, ID Mary. By the way, I need to close the bracket. Good catch. ID 2, name Mary. So looking at the brackets and indentation, JSON helps us to understand how the data is structured. And this is again non-relational because we go through the data, we can comb through the data and scroll down. But JSON lets us to nest the data. Nesting means nothing by, for example, ID1 and name, we can open another bracket instead of John, we can open another bracket and put Anne, right? And put several names. Or under name, we can define another name, bracket, let's say American, and then list American names with this ID. Or we can list European names, English names, etc., etc. So JSON allows us to nest that data, which is very different from how the data presented in relational databases. In non-relational databases, syntax matters. So if something is wrong in your JSON syntax and you're trying to upload your database information into some database management system and something is wrong with your syntax, the file will not be uploaded. You will have problems until you check the syntax. There are a couple of services available online that help you to check JSON syntax. You just upload the file and they let you know what's wrong. When we mention database systems, there are a lot of different database systems that allow us to manage the database, and there are different systems for each use case. So as I said, there are MySQL, Oracle, PostgreSQL, MongoDB, Redis. There is a database called Neptune, Amazon Neptune, which helps us to store the data for social media. Information. So one user has put likes, has put comments, has commented in groups, and in order to have this visual database of interaction between users, it's usually kept in database systems like Neptune. Now, I mentioned in the beginning of this video that we interact with databases on a daily basis. We just don't know about it. And it's time for us to look on how the 2-tier or 3-tier architecture looks like when database is into play. So usually a client, a browser, for example, it can be us, right, interacts with a web server. Say I want to create my bank account, or more so, I want to update my phone number in my bank account. I log into my bank application, right? I navigate to my personal details and then change my number. Probably I will have to confirm it with a code that comes to my number. Imagine I confirmed it. And then a query language, using a query language, SQL query language, will update the record for mobile number in my database. For example, if my bank account ID is 112 and number, okay, ID number, my number will be deleted, old number, and they will put a new number, 0007. Okay, so that's how I renew the records, and that's how many web servers operate, especially if they have data stored in a database format. You might think that, okay, it's only related to websites like banks, like hospitals, or like, I don't know, wherever we have login details, but that's not true. This is also related to websites retail websites. So Amazon can have all of their products that they're selling on their data in the database, and database is populated with information like product description, and then the product pages are fetched from the database, from the product information like product number, product name, product price. Everything is fetched from the database, and the page is populated, page that you see when you scroll through the product description, product information, etc., etc. So databases are very, very widely used, and this is a two-tier, very, very basic two-tier architecture. When they say a basic three-tier architecture, so for example, not long ago, I passed my AWS exam. And there you might see that if you look through the questions, or if you will be preparing for this exam, they like asking basic two-tier architecture or basic three-tier architecture. What does it mean? In a three-tier architecture, we usually have something in front of web server. It can be CDN, Content Delivery Network, the caching layer, or it can be a load balancer, right? In order to balance the load between different web servers. And then comes web server, and then comes a database. So the last two legs of the architecture are the same. We only have something in front of the web server to increase its high availability. So if there is a lot of traffic, the information can be cached and distributed to users based on their geolocation, or we can have a load balancer that distributes the load between web servers. If you have any questions about database, or if you would like me to make a more specific video about SQL or about any of the database types, please let me know in the comment section down below. Thank you for being with me today, and don't forget to subscribe to my channel and to like this video. See you in my next video. Bye!